PowerShell workflow, overview, and walkthrough. Now, this is a little bit of a complicated topic. Workflow was introduced in PowerShell version 3. So that's what you're going to see me using. I will be working on my Windows 8 computer. It is also present in version 4. There were a couple of improvements made to PowerShell workflow in version 4, and I will cover those kind of after we do the main walkthrough. The difficulty with PowerShell workflow and where I think it will limit you and how you use it is in how it works. So we're going to start with a little bit of an overview so that you kind of know where this thing is scoped into. The next set of nuggets we look at are going to be desired state configuration. And I think a lot of the use cases that people think workflow is good for are better served by desired state configuration, or DSC. So I'll try to provide you some guidance as we go about where this might work and where this might not work so that you can kind of understand when it's appropriate. This is the only nugget I do have on workflow, though. For the most part, using workflow is a lot like writing any other PowerShell function or script. It just differs in how it executes and what you do with it. So I'm going to start with a quick explanation of what workflow is and how it works. A lot of people are very excited about workflow when they first hear about it, but I'm going to talk about the ups and the downs. There's good sides, there's bad sides. It has some power, but there's a price to pay. I'm going to walk you through a very simple workflow example. I want to stay focused on the bits of this that are actually workflow. I don't want to get bogged down in writing code to provision an Exchange server. The code you write to accomplish your task is a separate issue. Packaging all that as a workflow and getting it working is what we're going to focus on here. And I'll also cover some of the key workflow features so that you know what this thing can do. We're going to start here in my Windows 8 computer running PowerShell version 3. That's where workflow was first introduced. None of these features are going to be available to you in PowerShell version 2. And let's start by talking about how this thing works. We've really got two sets of executables. PowerShell itself, where you're going to write your workflow, and then the Windows Workflow Foundation, or WWF. This is what's going to actually run your workflow. So you come over here into PowerShell, perhaps you're using the PowerShell ISE, and you write a little workflow script. Now when you run that, PowerShell translates it into XAML. It's an XML-based markup language for applications, and that gets fed to workflow. Workflow is what is actually running your code. So there are some differences in how you write these workflows apart from, versus a normal PowerShell script. Because at the end of the day, PowerShell is not going to be running your script. So let's start with a piece of terminology. In the Windows PowerShell world, we have commandlets, right? You've got commandlets like get process, you've got export CSV, you've got format table, you've got all these different commandlets. Sometimes they're functions, just generically they're called commands. And this is on the PowerShell side. Well, on the Windows Workflow Foundation side, which is what's actually running this, you don't have commandlets. You have activities. Activities. Oh, I spelled that right. The PowerShell team has created activities that correspond to most of PowerShell's built-in commandlets. So there is an activity called get process. If you start using commands that aren't a part of the set of core PowerShell commandlets, then there might not be an activity corresponding. In other words, Windows Workflow Foundation can't just arbitrarily run any old PowerShell command. However, PowerShell is smart enough to know, hey, he used this command that let's say it's export CSV. I don't know that doesn't have an activity, but let's just take it as an example. PowerShell is smart enough to go, hey, he used this command that doesn't have an equivalent activity. So when I translate that to workflow, I'm going to use workflow's inline script activity. And in that script, I'm going to run export CSV, or whatever the command is. Essentially, I'm going to have workflow run this activity, and then I'm going to have workflow launch PowerShell and run this command, and then continue on with whatever it's doing. That behavior markedly changes the way you need to think about designing your scripts. Keep in mind, every time you run a workflow, it is being executed by a completely foreign entity, so it has slightly different rules. And those rules are some of the things we're going to cover as I start talking about the different features of workflow. So I've opened my PowerShell ISE and I've run get module minus list available. Sorry about that. Get module minus list available right there. You can see that one of the modules that's on this computer, because it has PowerShell version 3, is PS Workflow and PS Workflow Utility. In PowerShell version 3, before you can begin using workflow, in fact, before its help files will even show up, you have to import the module. Now you don't have to do that in PowerShell version 4 and later. It'll automatically get you the help files at least without you having to manually import those modules. Now that I've imported them into my environment, I can start working with them. Now at its extremely most basic form, a workflow looks a lot like a function. So we would do a function like this. I'm just going to call it my complicated task. The difference with workflow is that instead of the function keyword, you do that. That tells PowerShell when I run the command called my complicated task, instead of running it yourself, you're going to need to translate it into workflow and hand it off to the workflow engine for execution. Now, just like a function, we can add a parameter block in here. And we can add our own parameters. But once you declare something as a workflow, it automatically picks up a whole bunch of built-in parameters. So it's worth talking about what those are, because depending on what it is you want to do, you might want to use one of the built-in parameters rather than trying to code it up on your own. Let PowerShell do more of the work if it's willing to, right? So just down here in a little help block so you can see them, I'm going to walk through what some of the more useful common parameters are. And one of the first ones you're going to want to know about is PS computer name. Now inside your workflow, you're going to access this with $PS computer name. When someone runs the workflow, they'll provide values to the -PS computer name parameter, just like the parameter of any other PowerShell command. So the idea here is that if someone provides computer names, and so, for example, let's just toss in an example. Let's say I run my complicated task minus PS computer name, I don't know, dc.lab.pri, member.lab.pri. My computer is going to convert this workflow into workflow language, hand it off to the workflow engine on my computer. The workflow engine will then send all of these instructions to both of those computers, and they will actually be the ones running the workflow. So I write my workflow as if it's going to be, I write it so that it's running locally. Any resources I need to access anything else, I assume they're going to be local. So I don't need to write any code that's going to enumerate computer names, that's going to connect to the remote computers. I don't need to do any of that. I just write this as if I was going to manually run it directly on the console of each of these computers. But when I run it on my computer, it will get pushed out to them automatically, and it will run on those. So that's really useful. That actually takes a lot of work off of your hands. Now, how is workflow and PowerShell actually getting that stuff to the remote computers? Well, the answer, my friend, is blowing in the wind. No, the answer is PowerShell remoting. Check this out. Get PS session configuration. You will notice when you enable remoting on a machine that's running PowerShell version 3 or later, it creates this Microsoft.PowerShell session configuration or endpoint. Now that's what we typically use for remoting. If you're using enter PS session or invoke command, that's what they connect to by default. But it also sets them an endpoint for workflow. So any workflows that you try to push to a remote computer by running the workflow and using the -ps computer name parameter, any of those will be pushed to this endpoint instead. So workflow has kind of its own little private connection that it can use. What that means though is if you want to use -ps computer name, you have to have remoting enabled on all of the target computers you specify. Now, as we covered way back when we talked about remoting, remoting is enabled by default on Windows Server 2012 and later, server operating systems. If you're going to use this against client operating systems, you've got to take the steps necessary to make sure that remoting is up and configured. Now, there's another one here. My $PS credential, which is what you would use in your script. Someone running the script would provide -ps credential with an A, not an S. And this is basically the credential that will be used to execute the entire workflow. So if I'm logged onto my computer as an unprivileged user, but I want the workflow to execute under elevated credentials, I can provide that alternate credential right there, and that'll be used to execute all of them. There's another one, $PS persist. And someone's going to run this with PS persist. This isn't necessarily one you need to care a lot about. I guess PS credential isn't really either. If someone runs it with PS credential, you're not necessarily going to use this in your script. Workflow is going to use it. Kind of the same thing with this one. -PS persist forces the workflow to save itself, to save its progress, to save its data and its state after executing each step. That means if it ends for some reason, it's able to resume and pick up where it left off. And that's something we're going to talk about a little bit later in this nugget. The last one, $PS parameter collection. That's actually a list of hash tables that specify all the different parameter values for each target computer. So again, we've provided PS computer name, right? Meaning I can target my workflow to multiple computers. And here's an example of how to do that. Well, what if there's some different values? Let's say, for example, I have a parameter and it's a string folder name. Let's say my workflow is going to create a folder structure on the remote computers. And so I need to know what that folder name is going to be. But it's going to be different for each computer. Well, PS parameter collection allows me to feed a unique set of parameter values for each computer I send the workflow to. So that's kind of neat. It's something that you can, it gets a little tricky to think about sometimes, but it definitely gives you a cool set of functionality. So those are some of the things that workflow does. Now, or the common parameters that workflow provides. Now I want to talk a little bit more about this idea of persisting information. When you start a workflow, keep in mind this is running in the workflow engine, it is able to save any top level variables. So it's able to save the value of this. That's a top level variable, so it's able to save that. And it's capable of saving that data to disk. It actually saves it in kind of an XML format. It's able to save that to disk as it goes. So as it goes, you can save your progress. That way, if the computer crashes or loses network connectivity or whatever else, you can resume the workflow right where it left off because you've saved all of its operating information. And it'll remember, yeah, I got line 8 finished, so I'm going to pick up on line 9 now when I resume. In fact, there's even some, here, let's hop down to a command window so I can show you. Import, remember, you got to import the module on version 3 before it'll be able to see it. And now let's ask for help on workflow, because we're going to find some commands including, let's see, about, here it is, help about checkpoint workflow. So there is an activity. Remember, workflows have activities, not commands. In a workflow, you can issue the checkpoint workflow activity, and that will take a checkpoint. So it saves the state, it saves the data. You can then suspend the workflow. Let's say you've got a long-running task that halfway through requires someone to take some manual action. I'm setting up a new server. I'm going to install the operating system. I'm going to do this. I'm going to do that. I'm going to do that. But then I want to suspend myself. I want to send an email to an admin that says, hey, the server's ready to be put into its rack. And then I want to suspend the workflow. Okay, admin walks in, picks up the machine, puts it in the rack. He can then resume that workflow, and I'll pick up with the workflow right where I left off. So there are commands for that as well. There's suspend workflow and resume workflow. So you can see there's a thing here for suspend workflow. So it's really kind of cool that it does that, but there are limitations on it. It's not perfect. It really, in terms of saving its place in data, it's kind of got to be this top level stuff. And you'll see what I mean about once we start talking about some more features. And we'll leave that in there for right now. Once we start talking about some more features, you'll understand what I mean by top level. In fact, we can talk about that a little bit now because variables are a great way to do that. Let's take myvar equal to 5. Let's do a write output. Now I'm going to increment that. Myvar plus equals 5. So 5 and 5 should be 10. That's my expectation. Hopefully we'll see. I didn't always do well at math. And I'm going to put a command in here that just runs the workflow. And that's all I have to do is just give it the command name. PowerShell is going to see that it's a workflow. Let's save this first because it does need to be saved. C workflow ps1. And then we'll run this. Wop, wop, wah. So this is the first thing you tend to run into. Workflow doesn't like positional parameters. It wants you to use the complete parameter name. So here in my write command, I used the complete, a positional parameter. I didn't use the complete parameter name. I also tend to not like using aliases in workflows. I'm not a big fan of them all the time anyway. So now you've got to figure out exactly what parameter it is. Oops, what parameter is it that you typically use when you use write output? Well, help write. And what you're probably passing things to there is its only parameter, minus input object. So we've actually got to specify that. Let's try running it again. Now, you notice there was a little delay there while it compiled it to workflow and handed it off, but we got the output we expected. Now, what I'm doing here is not running the write output command. Remember, there's an activity in workflow that happens to have the same name as the command. Here's where you can get yourself in trouble. I'm going to give you sort of walk into an example of this. Another activity, now this isn't at all legal in a plain PowerShell script, but it's completely legal in a workflow, is called inline script. I want you to try and think about what you think is going to happen. Obviously, myvar is 5, and it printed 5. We added 5, so that made it 10, and it printed 10. We've already done that. Let's put it in dual screen mode here. So we got 5 and 10 right there. Now, in the inline script, I'm adding 100. So in theory, this would output 110. But then you need to decide what this is going to output. Does it also output 110, or does it output something different? Let's run it and find out. You notice there was a delay after this because workflow was actually booting up a copy of PowerShell and running it. And this might not have been what you expected at all. Everything in an inline script is run in a fresh copy of PowerShell that does not inherit anything from the workflow itself. So in this fresh copy of PowerShell, myvar started out as nothing, and then we added 100 to it, so that's why this command displayed 100. Then that copy of PowerShell finished running, the process ended, and everything in it went away, and we came back to the workflow, and ran our write output activity. Well, from the workflow's perspective, my var never changed. So anything that goes into an inline script is run by PowerShell and becomes completely separated from the rest of the workflow. Watch this. I'm going to run this whole thing again. Save it. Now, if you remember the first time I ran this, I got an error because I was not using the minus input object parameter. Why is it okay with it here? Well, because everything in the inline script is not being run by workflow. Workflow is actually launching a copy of PowerShell, and PowerShell is perfectly happy with positional parameters. So this works fine because it's running in a copy of PowerShell. Now let's make this really complicated. I'm going to delete all this because now that we've kind of covered that theory, I want to show you something that's a little bit more realistic in terms of a gotcha with this. So I'm just creating a blank object here. And I'm going to pipe it to add member. And I'm going to add a member type note property. And I'm going to name it Fred. And I'm going to give it the value Barney. And then I'm going to write that to the pipeline. Okay, let's clear my little dual pane screen down there and run this. Right? We sure didn't get what you expected. Well, the problem is that some commands like add member don't exist as standalone activities. And there's not really an easy way for you to tell what is what. What happened here, remember, whenever PowerShell sees a command that it can't translate to an activity, it implicitly wraps the whole thing in an inline script. So this is what actually occurred. And this is one of the reasons that I think workflow is maybe more complicated than it needs to be. Sure, we created a new object, but then that copy of PowerShell shut down completely and it went away. Here, I said, hey, take nothing and add a member to it. And PowerShell probably said something like, all right. But then I shut down the copy of PowerShell and it went away completely. So here, this is the only activity that actually was run by workflow. Obj was nothing. And so that's what I got as my output, nothing. Other than this, you know, the output you always get when you run a workflow telling you what the job instance ID was. So this whole business of scope being very, very different, and some commands running as activities, but other commands being invisibly wrapped in an inline script can make writing workflows very, very difficult. In fact, I know a lot of folks who, when they sit down to write a workflow, will just wrap the entire thing. That way they know this is just a PowerShell script. All the information in there can be used by every command in there, and everything runs as a PowerShell command. The problem is you can't do any checkpointing in the middle of that. The only checkpoint you can do would be before the inline script, which there's no point because there's nothing before it, or after the inline script, which there's no point because there's nothing after it. So why checkpoint it? And so if you come to the point where you realize you're writing a workflow and the only way you can do it is to have everything wrapped in an inline script, you probably should have just written a function or a script. You're really probably not leveraging workflow very much. You could still push this thing out to multiple computers more easily by using the -ps computer name built-in parameter, but that's probably the only advantage you're going to get. Now we're going to spend some time talking about the features workflow can do, but there's a short list of things it cannot do, and I want to cover those. First of all, if you remember from our discussion on advanced functions, some advanced functions can use a begin, process, and end script block. Workflows do not. Workflows do support error handling, but they only support it outside of an inline script, that is. They only support the try, catch style of error handling. They do not support the older trap style. They're not designed to be interactive. That means you can't use write host, you can't use read host. You got to imagine that your entire workflow is running as a scheduled task, so there's no user in front of it to respond. Workflows also do not support comment-based help the way that advanced functions do. You can put as many they support comments. You can put all the comments you want to. That's fine if you want to provide inline documentation, but they don't support the specific comment-based help. If you want to provide a PowerShell-friendly help file for your workflow command, it's got to be written in the Microsoft Assistant's markup language, MAML. So it's an XML format that Microsoft uses to produce multilingual help files for their commands. So just a quick little talk about some of the things it can't do. Now, I'm going to clean up just a little bit, and we're going to talk about some of the things it can do. And the first of those is parallelism. First of all, if I was to run my complicated task with PS computer name, and I provided multiple computers, dc.lab.pri, member.lab.pri, it is automatically going to parallelize that effort. In other words, both of these computers will receive the workflow at roughly the same time. There's a built-in throttle of about 32 connections simultaneously. You can change that throttle if you want to, but by and large, it's going to parallelize that. Within the workflow, you can do another trick. So let's say I had folder names. Ooh, let's do better than this. Let's do folder paths. And let's say that each of those is going to be a complete path, but my parameter is going to accept more than one of them. And all I need this to do is create all of those folders. Well, there's no reason to run through them one at a time. I mean, provided they don't depend on each other, right? Like if I want to create C matches.fred, then I got to make sure C matches already exists. But let's say that's not the case. Let's say I'm going to provide folder paths like right? So there's no dependency. I can create all of these simultaneously. Well, PowerShell is perfectly willing to help you do that. And there's a couple of ways you could choose to do it. Let's look at the first, which is a for each construct. And it's for each. And because I'm in a workflow, I can add parallel. And I've got to say folder in folder paths. Let's see, this is called new item, item type, directory, and the name is going to be whatever the folder name is. Now this is being pushed out to 2 computers in parallel. Each computer is being asked to create 3 folders, and PowerShell workflow will create those 3 folders in parallel. It's not going to do this one, then this one, then this one. It's going to do them all at once. And the 2 machines are independently going to be doing that at roughly the same time also. So that's one way to do some parallelism. If you've got a bunch of things to work with, you can pull them out one at a time, but this will actually spin them off on separate threads. There's also, entirely within a workflow, a special block you can use called parallel. Any commands that appear within this parallel block will all execute more or less at the same time, and you don't even know that they will execute in the strict order you provide. Oops, process. Each of these 3 commands will now run more or less simultaneously, and they might not run in the order I've listed them. Sometimes you need to make sure things occur in a particular order, and so you can have a sequence. Now, those 3 commands will run in that order. Let's make a second sequence. Those 2 will run in the order I've asked. And now, here's the fun part. Let's wrap those 2 sequences in a parallel. That means this and this will all kick off simultaneously. So this block will run and this block will run next to each other. This one will do that command, then that, while this one is doing that and then that. So you can get quite complicated with the parallelization, and that's one of the unique things about workflow, is that you can get multiple things running simultaneously. So if you've got long running tasks that you need it to run, you can help speed that up a little bit by running those things in parallel. So just for fun, I've actually run this a few times, so I'm thinking that when I try to create actually, you know what? Here, let's just do a little preemptive fixing. Enter ps session dc.lab.pri. I'm just curious. Okay, so I don't have a 1, 2, or 3 on that computer. Enter ps session member.lab.pri. Oops. ls. All right, that one also does not have a C1, 2, or 3 folder. So in theory, I can run this. Let's see what happens. Now, I saw some errors, but I see information coming by too. Let's go review some of that. Let's get this thing full screen. So this looks like some of the event log entries I asked for. It's coming from the DC computer. Yeah, right there's the DC. So we'll keep scrolling up. And it's possible that the output can get interleaved. So I'm just kind of scanning here. Yeah, maybe I should have asked for fewer than 100. Let's grab this thing and scroll up a lot. Oh, so there's services. So we got our services. And now some more log entries. These are from member.lab.pri. So even though it was the second computer listed, it was the first one to get back to me with information. That's kind of cool. And I know we had some errors. I'm still looking for those. There's its services. There's its so processes from member, and then there's processes from DC. So that the output of these two has gotten interleaved, and you have to be prepared for that. You have to be able to capture the output and figure out how you're going to sort it. This looks like Active Directory computers that I asked for. And here's the first error. So on member.lab.pri, it was unable to run get AD computer probably because it doesn't actually have that command installed. I probably don't have the AD commands over there. And it looks like it did not like the path format that I provided for my, so it was not able to create those paths. But still, all in all, that's pretty cool. I think it's pretty neat that it was able to create all of that and retrieve all that information and actually run it. So that's essentially what a workflow looks like. We've talked about sequences. We've talked about parallelism. You can have deliberate inline scripts, but be aware that it will do some things as an implicit inline script, and there's not a really easy way to tell the difference all the time. So you've got to be kind of a little bit careful with it. And then troubleshooting workflows can get difficult. You almost have to build in your own logging mechanism so that you can write a log to the local machine and then go retrieve that thing later, because this isn't running as PowerShell. You might, for example, want to write events to the event log. That wouldn't be a bad way to do it. I've switched over to my Windows 8.1 computer because that's where I've got Windows PowerShell 4 installed, and I'm looking at the help file called About Windows PowerShell 4.0. And if you scroll down a bit, there's actually a section on what's new in PowerShell workflow. So I'm just going to kind of briefly cover some of these things. There's not a ton of them. Number one, there's a new pipeline variable common parameter, so that when you run a workflow, you can use this common parameter to capture the things that are in a pipeline. That's really useful when you're running scripts or workflows from inside System Center Orchestrator. Another one, let's see, custom container activities. After a crash, Windows PowerShell workflow will automatically reconnect to the nodes you're managing. You can now specify a throttle on the for each parallel so that you can control how many parallel things happen. It notes that parameter binding has been significantly enhanced. You can provide shortcut parameter names, in other words, the truncated parameter names, instead of having to spell them out completely. And also the remoting endpoint for workflow will now automatically close if there's nothing active, just to save a little bit of overhead on the computer that's running the workflows. Not a ton of new stuff. There's also some slightly better support for debugging workflows, and if you're interested in that, you can certainly read about it by going through this help file. Or another thing you can do is ask for help with everything containing the word workflow, and you'll get several different things here. Workflow common parameters, suspending workflows, about workflows is a good place to start too, if you want to learn more about this. So now you have an idea of how workflow actually works. The idea of translating PowerShell syntax into workflow syntax and completely handing that off to be executed by different code is what makes workflow a little bit complicated. The debugging is a little more complicated. Planning for it, kind of wrapping your head around it at all, is a little bit more complicated. But I did walk you through an example workflow, a fairly simple one, but one that at least illustrates the basic structure. You know, I mean, it's up to you to come up with the code that actually does what you need done. But I think in some cases, particularly when it comes to provisioning and configuring computers, you might see that desired state configuration, which is the subject of our next nugget, is a little bit easier and maybe better suited for the task. We also covered some key workflow features so that you at least have an idea of what this thing can do and where it might come in handy in your environment. I hope this has been informative for you, and I'd like to thank you for viewing.